Derek, can you introduce yourself to our audience?
Sure. I'm Derek Dunn-Rankin. I'm a professor in mechanical and aerospace engineering at the University of California, Irvine.
Okay, and what is your role on the Advanced Combustion via Microgravity Experiments project?
I'm one of the principal investigators as part of the ACME suite of experiments. My experiment is the E-field experiment. We're studying the effects of electric fields on flames.
Okay. Can you describe a little bit more about what happens in that experiment?
Yeah, sure. But I thought I would start by saying that people often ask why study combustion in general, and then why study it in microgravity. And just so people should understand that humans have been trying to control fire since the beginning of their existence. In fact, has been important for all of their livelihood. How to even eat food that is safer is by cooking it. And so that at the start of that, and then we've gotten better and better at using all this fuel that is abundant on Earth. And in the same process, we've been affecting the environment. And so this control of combustion started at the very beginning of human existence, and it's bound to continue through the rest of human existence. So combustion as a fundamental process is really important. It does everything. It processes materials, it creates fertilizer for the food we grow, and of course it lets us get around in our cars and airplanes. So the real question is, how do you control this really dominant form of energy? And to understand flames at a level that is necessary to control them, you have to study them in great detail. What happens in Earth experiments is that there's a very complicated environment where the flames are affected by gravity, they're affected by the flows, and that makes it very difficult to understand what's going on. My experiment adds another layer of complexity because we have flames that now create chemi-ions, and these ions are charged particles that if you apply an electric field, you can drag these ions around in the flame, and you have another lever, another way to control that combustion, which is really always about improving efficiency, reducing emissions. And so this is just another way that we can do that using some things that happen chemically, automatically in the flame that people don't study very often. So our subject is to look and see, can we get a much better feel for where these ions are coming from, how we can pull on them in ways that make flames more efficient and less emitting. And so in order to do that, we need an environment where we can isolate that behavior, we can isolate that property. And honestly, the only way to do it is to get rid of gravity. Gravity gets in the way of our understanding, and so we have to find an environment where we can only study the effects of these electric fields on the flames, and that turns out to be a space experiment. So that's why I got really excited to have the opportunity to be part of this ACME suite of experiments. Every one of the team is doing something that is trying to identify ways of improving combustion. Ours is just one more lever, one more application.
That's great. So can you explain for somebody listening who might be interested in a career in combustion research, what was your path, or what would you recommend to them if they were interested in following your example?
The other reason besides the obvious importance of combustion in society, the other really important thing that happens in our nation is the development of an intellectual workforce that can solve really hard problems. And so when I started, I wasn't really that concerned about what problem to study. I just wanted to make sure it was something that was complicated, rich, challenging, had experimental pieces, had theory associated with it. And in my experience, combustion is one of the strongest fields that brings as many different pieces of our scientific understanding together as any field I've ever seen. So you have to know about thermodynamics and heat transfer and flows and fluid mechanics and energy transport. All of these things are crucial in combustion. And that means that students that study in this field have such a rich development of problem-solving skills that I am never concerned about where they might end up, what kind of problems they might end up solving. So I see it as a very rich environment. I've always felt that way. I continue to feel that way. And so anyone who steps into combustion, I think they find that it's an exciting environment. I think also the collegiality of the community is a really strong benefit. It's not like some fields where you have so much animosity because of the competitive nature of the field. In combustion, there's a much more collegial, cooperative environment where everyone knows that they can benefit from each other's work And that helps make it a rich and rewarding experience in all academic ways.
Well, thank you for introducing your experiment and yourself to us.
Yeah, you're very welcome. Thanks for giving me the opportunity to have such an experience.